So today we're going to look at the distance formula, which is connected to the Pythagorean theorem. So rather than have you memorize a formula, which might get you through a test, I'd rather have you understand what it is that you're doing and why you're doing it. So if you were to just look it up in the book, well, I'll show you that later. So hypothetically, we need to find the distance of that line, but it's not completely vertical or horizontal. What I can do then is drop down to vertical, drop over a horizontal, try doing that a little neater, and bring over a horizontal till I make a right triangle. And then whatever this distance is, that's going to be the change in x's on the Cartesian plane, which is just the xy axis. And this is just going to be the change in y's. So when you go to look up the distance formula, it's either going to show you it's this, which isn't that one leg squared plus the other leg squared equals the hypotenuse squared. And then I took the square root of both sides, so you just have d. Another way you'll see it written is x1 minus x2 squared plus y1 minus y2 squared. And these mean the same thing. So rather than that abstract notation, what I'd rather do is show you what it means. When you have just a vertical line, you can just go ahead and count it. 1, 2, 3, 4, 5. If it's completely vertical or horizontal, you can just go ahead and count it. That's just 5. This guy, on the other hand, I am going to want to drop down a vertical line and make a right triangle out of it. So my change in y's is 1, my change in x's is 2. Those are the numbers that you use in the Pythagorean theorem. So 1 squared is 1, 2 squared is 4. When I take the square root of that combined, we get the square root of 5. In Moodle tonight, I believe on all but the last problem, they want you to estimate to the tenths. So this one, I would say D is approximately 2.2. So then, for example, this problem, I drop down a vertical, I drop down a horizontal, and it doesn't matter if you build your right triangle on the top or the bottom. Either is fine. There's my right angle. So then I count 2, 4, 6, and this is 2, 4, 5. So then I have 5 squared plus 6 squared. Take the square root. 25 plus 30. So the square root of 55 is the exact. And then the estimate is 7.4. And you would do that with each of these. You just drop down a vertical and then build a horizontal over. So this is 1 by, that's 4 and 5, 9. So 9 squared plus 1 squared is root 82, which is about 9.1. And let's take a look at when they just give you the 2 points and it's not on the Cartesian plane. What I do is I bracket to the x's, so 0 minus a negative 5 is 5, and I'll bracket over to the y's. Negative 2 minus a negative 1 is negative 1. Then these are the numbers that I use in the Pythagorean theorem. So then negative 1 squared plus 5 squared is 1 plus 25, or the square root of 26, which is approximately 5.1. Round up. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.